vertex cover, edge cover, matching. These are the three concepts that we will study today. Okay, let's start now. In the last class, what we have seen independent set. Independent set, that is set of vertices, right? Yes or no? Independent set, that is basically that is vertex independent set, means you have set of vertices which are independent. Independent means they are non-adjacent, means they don't have any edge between them. Okay, correct. So this is your vertex independent set, right? Yes or no? So we already know what is independence number. What is that? Can anyone tell me? Independence number. Independence number. This is the size of largest independent set. This is the size of largest independent set. Very simple. Okay. So we have already seen what is the what is a vertex independent set. This we have already seen. Basically, this is a set of vertices. Remember, this is a set of vertices which are independent. Okay, means they are non-adjacent. They don't have any edge between them. Correct. So this is the idea. Now tell me, in this graph, can you notice in this graph, this if you notice, this xy is this maximal independent set. This x comma y, like this one, this x comma y is this maximal independent set. Can you add something more? Can you add something more? No. You can notice x comma y, they are non-adjacent. They don't have any edge between them. So this x comma y, this is independent set because they are non-adjacent. They don't have any edge between them. But you cannot add anything more. I cannot add anything more. So this is maximal. This xy, this is maximal. And what about this? What is the maximum independent set? What is the alpha of this graph? So if you call this graph G, then what is alpha of this graph? Means independence number. What is alpha of G? In alpha of G, this is basically the independence number. This is the independence number. So what is the independence number? Or I can say stability number. What is the stability number? That basically means, okay, what is the largest independent set that you can create? Largest independent set very easily you can create. So you can take WUV. Okay, so you can take these vertices. You can take these vertices, WUV, correct? So basically the number will be 3. Okay, so largest independent set, if you notice, this will be the maximum independent set. This will be the maximum. Very simple. Okay, now let's move on. One more thing. You already know the star graph, right? Okay, so let's take the star graph. You know star graph. Star graph means K1 comma N. This is your star graph. For example, I can say this is the star graph, like A, then you have B, then you have C, then you have D, then you have E, and then you have F. So this is your star graph, and this is your vertex A. Tell me, in this, can I say this is maximal independent set? Is this maximal independent set? Can I add something more? Yes, this is maximal. This is maximal independent set. I cannot add something more. And what is maximum? And what is the alpha of this graph? What is the independence number of this graph? Alpha of G. Alpha of G. What is the independence number of this graph? That will be 5. Because what is the largest? What is the maximum independent set? Maximum independent set. So the largest independent set that you can create, that will be B, C, D, E, F. This is the largest that you can create. Very simple. Okay, so like this, you already understand all these concepts. In this, what is the omega for this graph? What is the omega of this graph? Omega of this graph, that is your maximum click number. This is your maximum click number, correct? Very simple. Okay, because what is the largest complete subgraph you have? In this, what is the largest complete subgraph? So you can notice K2. K2 is the largest complete subgraph, K2. Okay, so finally I can say omega of G, that will be 2. Largest complete subgraph, that will be K2. Okay, now the next concept is vertex cover, edge cover. The name itself is telling you vertex cover, vertex cover, vertex cover, edge cover. So first let's see what is this vertex cover. This vertex cover, the name itself is telling you vertex cover. Actually, what we cover here, what we cover, vertices or edges? See, the name is vertex cover, but what it means vertices which will cover edges. Okay, here actually we cover edges. Let me tell you, here we have vertices which cover all edges. Vertices which cover all edges, which cover all edges. They should cover all the edges. So remember, actually, we are covering the edges. So okay, but we call it vertex cover because vertices which will cover all the edges. Let me explain this concept using this like using this scenario. So let's assume there is a museum. Okay, like for example, maybe okay, there is some museum. Okay, maybe like whatever. You have some I can say okay. So you have some hall, let's assume. Okay, so now in this hall, what you have? So for example, let's assume this type of situation you have in this hall. Okay, so let's assume this type of situation you have now. Okay, so this type of situation, some situation you have this like this type of hole is there. Okay, so like this type of situation you have. Now tell me one thing, tell me one thing. Actually these are the galleries. Okay, like here you have paintings. Okay, like let's assume here you have this is a some I can say this is a painting museum. I can say this is a painting museum. Then in this painting museum what you have? So you have, let's assume these are the galleries. Now okay, now these are the galleries you can notice. Then tell me how many security guards you need. Actually these are the galleries. So here here you have paintings, here you have paintings, like on these walls, on these walls you have paintings, on these walls you have paintings. Okay, then what we want, what we actually want, how many security guards will be there? Tell me how many security guards we need to cover all the paintings. Like we want to cover all the, we want to cover all the walls, we want to cover all the walls, all these walls we want to cover. Correct? Is this problem clear? So you have a painting museum. In this painting museum, how many security guards you need? So what is the very trivial answer? Can anyone give me very trivial answer? Anyone? Very trivial answer. 100 security guard. Yes or no? 100 security guard. Like one security guard you place everywhere. Yes or no? One here, 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 one here. Yes or no? This is a very trivial answer. Correct? Yes or no? Very simple. You don't have to apply your brain. But what is the interesting question? Tell me what is the interesting question? If I ask you, the interesting question is minimum number of security guard. Correct? Yes or no? So tell me, what is the minimum number of security guard that you need? Minimum number of security guard, such that they will cover all the walls. Minimum number of security guard. Okay. Tell me one thing. Okay, if you want to cover this, if you want to cover this, one security guard you need here. One security guard you need here. Now this security guard will cover this, this, and this complete. Okay, so this is covered. These walls are covered. Correct? This security guard can cover. Okay, if you put this security guard here, then this security guard can cover all these galleries. Next, one security guard you have to put here. Okay, what you can do, you can put one security guard here. This security guard will cover this gallery. Next, one security guard I can put here, and this security guard will cover all these. So how many minimum? Minimum how many you need? Minimum. So minimum we need 3. Yes or no? So I can say minimum size of vertex cover. Minimum size of vertex cover, that will be 3. Is this clear to everyone? So what is the vertex cover problem? This vertex cover problem is very simple, that you want to cover all the edges. Vertices which will cover all the edges. Remember, you have to cover all the edges. This is important. So you have to cover all the edges. Now, so let's see the terminology. If you have this graph, let me give you a graph A, B, C, D, okay, E. So let us assume this graph you have. Now in this graph, let's assume, tell me one thing. What are the edges that A will cover? Okay, this vertex A covers which edges? Covers which edges? This vertex A. Let's see which are the edges that are covered by vertices. So first here I will write the vertex, and here I will write the edges covered. Here I will write edges covered. Okay, so what are the, tell me, if I have this vertex, so tell me if I have this vertex, which edges will be covered? There will be 2 edges that will be covered. Okay, this AB edge will be covered and AC edge will be covered. You can clearly see because this A is covering these edges. So AB and AC, these edges will be covered. Okay, what are the edges covered by C? C will cover which edges? C will cover this edge. Remember AC and CA, they are same, yes or no? Remember this edge, this is just a convenience. I told you that this is just for convenience. This is just for convenience. This edge A comma C, this we will write as AC. And this is same as CA. They are basically same. Okay, this is the writing convenience. This is for convenience. For convenience, this is what we will do. This I told you. Okay, remember this edge you have. So this is your edge A comma C. This we will simply write as AC, or I can write it CA. Both are same. AC comma CA, both are same. Okay, so this C, this will cover which edges? AC comma CD. These edges will be covered by C. Which edges will be covered by B? This B will cover, AB edge will be covered, BE edge will be covered, BD edge will be covered. You can notice these edges are covered, and you can notice C will cover these edges. So like this you can say. And similarly, for finally I can say that, for example, E, what edges E will cover? E will cover, I can say E will cover BE edge and E will cover ED edge. So you can notice these two edges are covered by E. So this is simple. Okay, so this vertex, if you put a security guard here at this vertex, which edges will be covered? If you put the security guard here, then this and this edges will be covered. And if you put a security guard here, for example, if you put a security guard here, then this edge, this edge, this edge, these three edges will be covered by this security guard. Okay, so this is the idea. Now let's see the same thing I will do. If I put security guard on edges, what I do, I put security guard on edges, then which vertices are covered? If I put security guard on edges, for example, if I put a security guard on AB edge, then which vertices will be covered? One security guard I put here, one security guard I put here, then which vertices will be covered? Only A comma B, these vertices will be covered. If I put a security guard on ED edge, then only these vertices will be covered. Like if I put a security guard here, then this and this, these two vertices will be covered. And similarly, if I put a security guard at CD, then this C comma D, these will be covered. These vertices will be covered. So is this concept clear? So here you can notice, if I put security guard on vertices, then edges will be covered. So here vertices are covering edges, and here edges are covering vertices. Okay. So now what is vertex cover? What is vertex cover? Vertex cover means vertices will cover edges, and edge cover means edges will cover vertices. Okay, so this is the idea here. Vertices covering edges, vertices covering all edges. This is important. All edges must be covered. Okay, vertices covering all edges. And what is this edge cover? What is this edge cover? This is edges covering all vertices. Covering all vertices. Basically, tell me, in this scenario, where we put the security guard? Where we put the security guard in this scenario? For the edge cover. For the edge cover, the security guard we put at the edges. On the edges we put. Yes or no? Because edge cover means edges which cover all the vertices. So we will put the security guard on edges. Okay, so I can say that this is the idea. Vertices covering all the edges covering all the vertices. This is the simple idea. So here I can say the security guard, I can say the security guard, I can say where we put the security guard on vertices. We put security guard on vertices to cover edges, to cover all edges, to cover all edges. And the same scenario, here we put the security guard. Okay, here we put the security guard on edges. This security guard we put on edges to cover all vertices. To cover all vertices. Is this concept clear to everyone? What is vertex cover and what is edge cover? So don't confuse. Vertex cover simply means that you are putting the security guard on vertices. You want to cover all the edges. Okay. Edge cover means you are putting the security guard on edges. You are putting the security guard on edges. So you want to cover all the vertices. So this is the very simple point. Now, in both these scenario, what is interesting problem? For example, if I give you this A, B, C, D, okay, this graph I give you, E. Then tell me, is this interesting problem? Maximum vertex cover. Is this interesting problem? Tell me. Maximum vertex cover. Maximum vertex cover. Is this interesting problem? Maximum vertex cover. This is not interesting problem, because what will be your answer? There you don't even have to apply your brain. See, you don't even have to apply your brain. So this is not interesting problem. This maximum vertex cover is not an interesting problem, because you can simply do this. And is this interesting? Maximum edge cover. Maximum edge cover. Is this interesting? No. What you will do? Again, the same thing you will do. You will put the security guard everywhere. You will put the security guard everywhere. So of course, this is not an interesting problem. These two are definitely not interesting. These two are definitely trivial. These two are definitely trivial and not interesting. They are definitely not interesting, because what you are going to do, you will just put like here maximum edge cover. So what you will do, you will put security guard on all the edges, and here you will put security guard on all the vertices. So these are basically trivial and not interesting. So what is interesting? So what is interesting? The interesting problem. What is the interesting problem? That is the minimum. The interesting problem is basically the minimum vertex cover and minimum edge cover. This will be the interesting problem. Yes or no? So this minimum vertex cover and minimum edge cover, these are the interesting problems, these two. So finally, what is the minimum vertex cover? Minimum how many vertices I need? Minimum how many vertices I need to cover all the edges? I want to cover all the edges. I want to cover all the edges. See, I can put one security guard here. I can put one security guard here. So now these three edges are covered. These three edges are covered, and I can take B, C. Yes or no? Yes or no? This is the minimum vertex cover. You cannot cover all the edges by a single vertex. So this is the minimum vertex cover. And what about this minimum edge cover? In this minimum edge cover, we want to cover all the vertices we want to cover. So if you want to cover, for example, if you want to cover this, we want to cover all the vertices we want to cover. So for example, tell me, to cover this vertex, what is mandatory? I want to cover all the vertices by edges. What is mandatory? This BE edge is mandatory. This is mandatory. Yes or no? This edge we have to take. This is mandatory, because to cover this vertex, we definitely have to take this edge. Next, what we should do? So now these two vertices are covered. These two vertices are done. Now we have to cover these three vertices. These two vertices we have done. So see, B, E, these two vertices we have covered. Now I can take A, C. These two vertices are done. One vertex is remaining. One vertex is remaining. So now you can notice all the vertices are covered. Now you can notice all the vertices are covered. So the minimum edge cover, that has size 3, and minimum vertex cover, that has size 2. Is this clear? The concept of vertex cover, edge cover. In vertex cover, we find set of vertices which will cover all the edges. In edge cover, we find set of edges which will cover all the vertices. You can notice this will cover B, E. This will cover A, C. This will cover B, D. So now you can notice all the vertices we have covered. Every vertex has been covered, and here every edge has been covered. So this is the minimum vertex cover, and this is the minimum edge cover. Is this concept clear? Let's take another question. For example, if you consider this C, A, B, D, E. Okay, this is your graph. Tell me which is a vertex cover. I want to find which are the vertex cover. So can I say this is a vertex cover? Tell me which is a vertex cover. Is this a vertex cover? Is this a vertex cover? I am not asking minimum or maximum. I am asking vertex cover. Is this vertex cover? No, this is not a vertex cover. This is not a vertex cover. Okay, next, tell me A, D. Is this vertex cover? This is not vertex cover, because it will not cover all the edges. See, A, D. If you put one security guard here, one security guard here, then these two security guard cannot cover these two galleries. These two galleries cannot be covered. So this is not a vertex cover. So tell me, A, B, C, D, E. Is this vertex cover? Is this a vertex cover? Yes, this is a vertex cover, because it will cover all the edges. It will cover all the edges. Every edge has been covered. Now tell me, is this a vertex cover? Is this a vertex cover? Yes, this is a vertex cover. And tell me, A, comma, B, comma, E, comma, D. Is this a vertex cover? Is this a vertex cover? Yes, this is also a vertex cover. Tell me one thing. Is this minimal? Is this minimal? Is this minimal? Can I say this is minimal? This is not minimal. Why this is not minimal? See, for example, if one security guard is here, 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 are they minimal? Are they minimal? No, you can remove something. Yes or no? They are not minimal. You can remove something. For example, you can remove C. You can remove this C. So this is not minimal, I can say. What about this? Is this minimal? Is this minimal? Can you remove something? Can you remove something? Is this minimal? Can you remove something? From this, can you remove something? Yes, this is minimal, right? You cannot remove something. We cannot remove anything. This is minimal. And this is also minimal, and this is minimum. This is minimum. Yes or no? Is this clear to everyone? The concept of vertex cover. So remember, this is also a vertex cover. This is also a vertex cover because it will cover all the edges. This will also cover all the edges. This will also cover all the edges. You can notice this is not minimal because you can remove C. You can remove C. You don't need C. This security guard you don't need. This is not minimal. You cannot remove anything. And this is minimal, also minimum. This is minimal also and minimum also. Okay, you cannot remove anything, and this is the minimum. Now the same thing can we do for edge cover. What can you say about the edge cover? Which of the following is the edge cover? Like for example, can I say this CB? Is this the edge cover? This C comma B, sorry, this CB, this edge CB, is this the edge cover? This is not the edge cover. Which edge, which vertices this is covering? This is covering only C comma B. Only C comma B. These two vertices are covered, but the remaining vertices are not covered. Okay. Now, next, tell me one thing. What do you think? Minimum, how many edges we need to cover all the vertices? Minimum, how many edges we need? Remember, one edge will cover how many vertices? One edge will cover how many vertices? One edge will cover only two vertices. For example, I can take CB. This CB will cover C comma B. These two are covered. So now C comma B are covered. Now I can take AC. Now these two are covered. Now what is remaining? What is remaining? So CB, AC. I have to take CD to cover this, and I have to take EC. So actually this is the edge cover. Yes or no? This will be the edge cover. Actually, this is minimum also. This is minimum also. This is minimum edge cover. Is this clear? Okay. The concept. Tell me, this is interesting thing. One edge will cover how many vertices? One edge can cover how many vertices? One edge covers exactly two vertices, right? One edge covers exactly two vertices. One edge will cover exactly two vertices, not more than one, not more than two, not less than two. One edge will cover, okay, because if you have this edge, for example, this edge you have where you have U comma V, then this edge, if you notice, this edge E, I can say E covers U comma V. These two vertices, this E will cover. And what about vertex? What about vertex? One vertex can cover how many edges? One vertex can cover how many edges? Can cover any number of edges. Can cover any number of edges. Can cover any number of edges. Okay, remember, one vertex can cover any number of edges. There is no limitation. One vertex can cover any number of edges. For example, here you can notice this C, A, B, D, E. Here you can notice this C is covering all the edges. This vertex C covers all edges. Here, all the edges are covered by this vertex C. And here you can notice this C, A, B, D. Here this C is covering how many edges? Here this C is covering how many edges? C covers only one edge. Here C covers only one edge. Okay. So basically, this is the idea. And what about this graph? Like A, B, C, D. Okay, what about this? This is your graph. Then tell me D covers how many edges? D covers no edge. D covers no edge. Okay, this D will not cover any edge. So tell me, for this graph, what will the vertex cover? Vertex cover means vertices which will cover all the edges, which will cover all the edges in this. So you can notice this will be your minimum vertex cover. This will be your vertex cover. A, B, C, this will be your vertex cover. And A, B, C, D, this also will be your vertex cover. Which is minimum? You can notice this is minimum. You can notice this minimum. Is this minimal? Is this minimal? Is this minimal? This is not minimal because you can remove something. And this is also not minimal. This is also not minimal. So this is the minimum vertex cover. Okay, yes or no? And D does not cover any edges. Okay, for this graph, if you have this same graph, you have A, B, C, D. And tell me what is the edge cover? For this graph, what is the edge cover? What is the edge cover of this graph? The edge cover, like edges which will cover all the vertices. Edges which will cover all the vertices. Edges which will cover all the vertices. Is it possible? Tell me, is it possible? Edges which will cover all the vertices. Okay, so this is the node. So let's take this is the node. So basically does not exist. I can say does not exist because you cannot cover all the vertices. Okay, edges which will cover all the vertices. You cannot cover all the vertices using edges. Yes or no? So this is the node. Edge cover exists. Edge cover exists when, tell me, if and only if and only if, when edge cover exists, if and only if no isolated vertex, if and only if no isolated vertex, no isolated vertex, if and only if no isolated vertex, अर्थात minimum degree should be greater than 0. This minimum degree should be greater than 0. For example, take this graph A, B, C, D, E. For this graph G, you can notice that minimum degree is greater than 0. Now, what is the edge cover of this graph? Can anyone tell me the edge cover of this graph? Edge cover means edges. So this will be your edge cover. This edge cover. Can I say this is minimal? Can I say this is minimal? This edge cover. This is not minimal. This is not minimal. So give me a minimum edge cover. So this is not minimal. Give me the minimum edge cover. So DE, AB. Now you can notice these vertices are covered. Only one vertex is remaining. Only one vertex is remaining. Now all the vertices are covered. So this is the minimum edge cover. I can also say DE. I can take A. I can take BC. I can take BC and AC. Okay. Now you can notice all are covered. All the vertices are covered. This is correct. Okay. So is this clear? Edge cover means edges which will cover all the vertices. Edge cover. So you can notice this is not minimal. This is not minimal. These are the minimum edge covers. These two are the minimum edge cover. Okay. Next, tell me, are the red vertices vertex cover? These red vertices, are they vertex cover? These red vertices, are they vertex cover? The answer is no, because this edge is not covered. This edge is not covered. This edge is not covered. So I can say this is not a vertex cover. What is the minimum vertex cover here? What is the size of minimum vertex, like minimum vertex cover? MVC. MVC means minimum vertex cover. Minimum vertex cover. Okay. And remember, size of minimum vertex cover. What we call it? Size of minimum vertex cover. Size of minimum vertex cover. We call it vertex cover number. We call it vertex covering number. Size of minimum vertex cover. Remember, this is called vertex covering number, and we denote by symbol beta. This beta symbol we use for vertex covering number. And the same thing we can do for edge cover. So what is minimum edge cover? This is your minimum edge cover. Okay. And what is the size of minimum edge cover? The size of minimum edge cover. Minimum edge cover, that is edge covering number. That is your edge covering number, the size of minimum edge cover. And the symbol for this is basically beta dash. Beta dash means this is beta, so here the symbol is actually beta dash. Okay, is this clear? Minimum edge cover. So tell me here, you can notice what is the minimum vertex cover. Give me a minimum vertex cover. Give me a minimum vertex cover. So you can notice that, see, I want a minimum vertex cover. I can take 3. I can take 3. I can take this 3. Okay, if I take this 3, then these edges are gone. If I take this 3, then these edges are gone. These edges will be gone. Okay, these edges we have covered. Now these edges are gone. Now what we can do? Now what we can do? We can take this 2 will cover these edges. If I take 2, these edges will be covered. Or what I can do? I can take 5, 1. I can take 5, 1. All the edges will be covered. Yes or no? 1, 5, 3. They will cover all the edges. 1, 5, 3. So this 1 will cover these edges. This 5 will cover these edges, and 3 will cover these edges. So this is a minimum vertex cover. Can you do with only 2 vertices? Can you do with only 2 vertices? Only 2 vertices can you do? Only 2 vertices can you do? No, 2 vertices are not enough, because one of them we have to take. Yes or no? We have to take one of them. One of them we have to take. One of them we have to take, definitely. So 2 is not enough. So finally the vertex cover number, what is that? Like vertex cover number means beta. Beta is actually 3. Beta means vertex cover number. And what is the minimum edge cover? What is the minimum edge cover? So we have to take this edge. This 3, 7 edge we have to take. This 1, 4 edge we have to take. Now these are covered. 4 vertices have been covered. We have covered these vertices. We have covered these vertices. Now we can take 2, 5 and 5, 6. Now we can take these vertices. So the edge cover number means this beta dash. This beta dash will be 4. Okay, is this clear? So quite simple. What about this? What about this question? Is this the vertex cover? Is this the vertex cover? This is not the vertex cover. So again, the answer is no, because not covered. Because this is not covered. Okay, you can notice if this is your graph, this is a vertex cover or not? This one. This the vertex cover, like these 3 red vertices. Yes, this is a vertex cover. All the edges are covered. But this is the minimum vertex cover. This is your minimum vertex cover. So I can say beta is equal to 2. For this graph, the beta will be equal to 2. Okay. So very simple. These concepts are actually very simple. Just apply the definition. These concepts are very simple. We have already seen vertex cover number, edge cover number, edge cover, vertex cover. All these concepts we have seen. Okay. Now, so this is your vertex cover. Like here, you can notice what is the minimum vertex cover. Here, the minimum vertex cover will be this vertex. This vertex will be the minimum vertex cover. Okay. Here, what is the minimum vertex cover? What is the minimum vertex cover? Here, you can notice that these 2 vertices which will cover all the edges. Okay. So like this you can see all these examples. Okay, let's see this question. Can you try this question? Like, okay, so can you try this question? Let me remove the answer. Now try this question. For this graph, tell me what is the vertex cover, like minimum vertex cover. Give me minimum vertex cover for this graph. What is the minimum vertex cover? What is the minimum edge cover? What is the maximum independent set? What is the minimum vertex cover, minimum edge cover? What is the independent maximum, largest, maximum independent set? Remember one thing, if I write MVC, what it means? It means minimum or maximum. It means minimum or maximum. It means minimum vertex cover, because we are only interested in minimum vertex cover. And if I write MIS, independent set, then what it means? Minimum or maximum? Minimum or maximum? Here it means maximum, maximum independent set. Because when you study independent set, maximum is what we want. If I ask you what this means? This means maximum clique. This means maximum clique. Okay, this means maximum click. Because okay, and tell me, if I write MEC, then what it will mean? If I write MEC, minimum or maximum? What this will mean, minimum or maximum? This will mean minimum. Because when you study edge cover, you want minimum. When you study vertex cover, you want minimum. When you study independent set, you want maximum. And when you study click, you want maximum. Correct? Is this clear to everyone? Because see, if I ask you minimum independent set, that is trivial. If I ask you minimum independent set, that is trivial, right? This is the minimum independent set. Minimum. So minimum is not interesting. Minimum independent set is not interesting. What is interesting? Maximum independent set is interesting. So here maximum independent set is interesting. Here maximum click is interesting. Okay, so let's see these questions. All these questions, let's answer them. So what will be the minimum vertex cover? I want a minimum vertex cover. What that will be? If I want minimum vertex cover, what that will be? 256. Okay. So 256, are they covering everything? Yes. 2,5, they will cover all these things. 2,5. Yes. 256. This seems very nice. Okay. Next. 57 is not covering everything. 57 is not covering everything. 57 is not covering this edge. 57 will not cover this edge. So this is minimum vertex cover. Okay. Next. So you cannot, this is your minimum vertex cover. Next, what is the edge cover? You want to cover all the edges. So I can take 6,7. Now these are done. 6,7 are gone. I can take 4,5. Now these are gone. 4,5 are gone. I can take 1,2. These are gone. So these vertices I have covered. Which vertex is remaining? Only vertex 3 is remaining. So 3,6. Now all the vertices we have covered. And what is the maximum independent set? Maximum independent set. Maximum independent set. I want independent set. So I can take this 7. I can take 3. I can take 7. I can take 3. See, this is a complete graph. So how many I can take from this? Tell me, from this how many I can take? Only one I can take. From this I can take only one. So I can take 7. I can take 3. Then I can take 1. Then I can take 4. So this is the maximum I can create. Yes or no? Very simple. So remember, this is your maximum independent set. And what is the maximum click? What is the maximum click? Maximum click. This will be the maximum complete subgraph. This is your maximum click. This is the maximum complete subgraph. So the maximum click, I can say omega is actually 4. Alpha is what? Alpha is also 4. So you cannot, this will give you alpha. Alpha will be 4. Omega is also 4. And what is beta? What is beta? This will give you beta. This will give you beta. Beta means vertex cover. So beta will be 3. And what is beta dash? Beta dash will be 4. Okay. Let's solve this question. What will be the answer? What is the size of, actually the question is asking size, then why the options are like this? Okay, anyway. So tell me, what is the size of minimum vertex cover? And the question is asking which of the following is a minimum vertex cover? Two questions you have. Which of the following is minimum vertex cover? And what is the size of minimum vertex cover? Size of minimum vertex cover, that means beta. What is your beta? So tell me, identify one of the minimum vertex cover. Is this minimum? Just tell me, is this minimum? BCD, FG, IJK. BCD, BCD means this BCD, FG, IJK. Is this minimum? Can you remove something? First of all, tell me, is this covering everything? Is this covering all the edges? Are we covering all the edges? Just check. Are we covering all the edges? First you check this. Are we covering all the edges? Yes, all the edges we are covering. But can we remove something? Can we remove something? Is this minimum? Actually, this is this minimum. Let's start with the minimum actually. Okay, see, always start with the minimum. What is the minimum size? Here you have from the options. Look at the options. This has size 8. this has size 8, and this has size 7, and this has size 8, and this has size 7. So always start with the minimum. Let's start with this 7. Is this a vertex cover? Is this a vertex cover? BCE FGIJK. BCE. Okay, BCE. Next FGIJK. Next FG FGIK. FGIK. Tell me, are all the edges covered? You can notice. See, one thing you see, one very interesting thing. Why I am writing these big circles? Why I am writing these big circles? Like why I am writing these big circles? Because it is telling me which edges are covered. It is telling me which edges are covered. Yes or no? In the GATE exam, if this question comes, these are telling me which edges are covered. These things are telling me which edges are covered. Okay. So that is the reason I am writing these big circles. So let's see this option. So for this option, you can notice these big things you can create B, C, E, F, because this will tell you which edges are covered. This will tell you which edges are covered. So are we covering all the edges? Did I leave any edge? Did we leave any edge? Oh, DJ. Oh, DJ is not covered. So this is not a vertex cover. Okay. DJ is not covered. So this is definitely not a vertex cover because this this is not covered. What about this? Okay, so this is not covered. Now, after this, let's see the next one. Let's see the next option. The next option. So this option is gone now. Now this option is gone. Let's see the next option. That is this option. Let's check. Let's check this option. Let us check. So BD. So now let me check this option. So this option is basically B, then you have D, then you have F, then you have G, then you have H. Okay, next you have I, next you have K. Did we leave any edge? Tell me, are all the edges covered? Are all the edges covered? Like, did we leave any edge? Just check. Yes, this edge is leave. This edge is left. See, this edge is left. This edge is left. So this is also not vertex cover. This is also not vertex cover. So this is also out of the picture. This option is also out of the picture. Now two options are remaining to you. Now let's check this option number C. This option number C, let's check. Option number C means ABC, ABC, E, H, J, K, L, J, K, L. Are they covering all the edges? Again, this edge is not covered. Again, this edge is not covered. So this is also not a vertex cover because this edge is not covered. So this is also gone out of the picture. This has gone, this has gone. So finally, the answer should be this. The answer should be this one. This would be the answer. Okay, anyway, let's check whether this is the answer or not. So BCD, then you have F, then you have G, then you have I, J, K, then you have I, J, K. Did we cover all the edges? Now tell me. Now we are covering all the edges, right? Now, yes, we are covering all the edges. So you can notice the beta will be actually 8. For this question, this will be the beta. Minimum vertex cover will have size 8. Okay. Tell me one more question. This is interesting question. The maximum degree vertex. What can you say about this? The maximum degree vertex. Should this be in vertex cover? The maximum degree vertex must be in vertex cover. Must be in minimum vertex cover. What about this? True or false? True or false? The maximum degree vertex, the vertex which has maximum degree, is it okay? It should definitely be in the minimum vertex cover. This statement is clearly false. This statement is false. You can easily create example. See, you can easily create a counter example. You can easily create a counter example. No, star graph is not a counter example. In the star graph, maximum degree vertex will be the minimum, will be in the minimum vertex cover. But you can create a counter example like this. What you can do, you can create a counter example like this: B, C, D, and then you can do E, F, G. Now take this. Tell me, what is the maximum degree? Which vertex has maximum degree? This vertex has maximum degree. All the vertices like these are 2, 2, 1, 1, 1. So all vertices, this vertex has the maximum degree. But what is the minimum vertex cover? What is the minimum vertex cover? Tell me the minimum vertex cover. The minimum vertex cover will be BCD. This BCD will be the minimum vertex cover. This BCD. Yes or no? So maximum degree vertex must be in minimum vertex. Maximum degree vertex must be in minimum vertex cover. This is false. Is this clear to everyone? A star graph is not a counter example. Don't say that a star graph is counter example. In a star graph, this is not a counter example, because in a star graph, A, B, C, D, E, F. In a star graph, this vertex has degree 5, and the minimum vertex cover is also this. So this is not a counter example. This is not a counter example. This is not a counter example. Actually, you can very easily create a counter example like this. So make a vertex, make a maximum degree vertex, and then just make sure that you don't get you don't take this in the minimum vertex cover. Very simply, you can do this.